These are the last types of questions that I want you to focus on when we're looking at finding max and minimum related to quadratic equations. Let's hide this question in a word problem. You've seen this in grade 10. You're seeing it again in grade 11. These are very popular word problems, and they're one of the best ways we can represent realistic aspects of quadratics, because people actually do this. They look at numbers sold, they look at ticket prices, they consider raising to maximize profit because any good business model always wants you to be maximizing profit. So let's have a little read. Student Council is running a talent show and we're raising money for charity. So last year, based on their sales, the tickets cost $11 each and 400 people went. So for $11 each, 400 people went. The Student Council has decided to raise the ticket price for every $1 increase. Okay, so they're going to raise the ticket price. But they've noticed that in the past, you can't do one thing without something equally and opposite happening. You tend to lose people attending because it's now more expensive. So the talent show attendance would decrease by 20 people. Okay, so now we have to make a revenue equation. So if I were going to ask you, how much money would you make if you sold hats, if you sold 20 hats for $10 each? You would take the number of hats that you sold and you'd multiply it by the price per hat. And that would give you your total or your revenue. Now, obviously, you'd like, oh, well, I put some money into it, so I'm going to take back my cut. That's my break even point, and then this is how much I made profit. But revenue just means the total amount earned. So for us, revenue has to happen when we look at number tickets sold. So if they sell 100 tickets, and then we have to multiply that by the price per ticket. Okay, so let's talk about the number of tickets sold. I have that in green. Last year, 400 people went, and there's going to be a decrease by 20. How many times are they going to decrease by 20? Are they going to decrease by 20? Are they going to decrease by 2 of them, 40? Are they going to decrease by 3 of them, 60? We don't know how many decreases are going to happen, but we know that the number 400 people is going to go down by 20 people. We just don't know how many times that's going to happen. Okay. We know that the price is $11. That was in red up here. And it's going to increase by $1 for every amount of increases and decreases. The reason this is exactly the same because if we go one decrease, it's minus 20 and it's a $1 increase. If we go two decreases, it would be minus 40 and it would be a 11 plus $2 increase. Okay, so that's why you've got X in both of those. Well, we have just created an ugly, very, very ugly, you don't like it, you hate math in general, equation that is actually in the form of this. Oh, Megan, that's not it at all. A x minus s, x minus t. You have created the factored form of an equation. And you're going to say, Miss, this doesn't look at all like this. You're not wrong. You're not wrong. Okay, but this is still a factored equation. And when we've got factored form, we can state the zeros. Way to go, Megan. Erase all the work. Let's try that again. Okay. So how do we state our zeros? It's the exact same process that we were doing over here. State our zeros. Well, we had nice brackets here. You were just like, oh yeah, zeros plus 2 and negative 6. Yeah, over here we've got uglier brackets. Still the same step though. Not moving that. Okay, so I'm going to make this whole bracket go to 0. What does she mean? I'm going to let 400 minus 20x. I'm going to make it go to 0 because I want to find out what this x value is that would make this bracket go to 0. It was easier with our other equations because we just did the opposite, but because this is uglier, we have to do some more math. So we want to set this whole bracket to 0. Let's isolate. Oh, the struggle is real today. Let's isolate for x down here. Let's subtract 400 from both sides. Sounds like a good plan. Boom. Now we get negative 20x. Don't make that negative disappear. Okay, respect that. Negative 400. Okay. And then we're going to do a little bit of this. Boom, boom. Negative 20. You are always, always, always going to use a calculator to check your answer. Negative divided by a negative is a positive. 400 divided by 20 is 20. 20 times 20 is 400. So 20. Let's find our 0 here. We're going to do the same idea. Let this bracket now go to 0 because we need to find out what this value, this one's easier than the other one, but we're still going to do it because it's good practice. Let 11x, 11 plus x go to 0. We're going to subtract 11 from both sides. We get x equals negative 11. So our two zeros are at 20 and negative 11. Okay, what price would maximize the revenue? This question wants to know what price would maximize this situation. So we need to find the vertex because it's asking for a maximum. Okay, we need to find the vertex. And now that we've got the zeros, our next step, this is step 1, find zeros. This is step 2, is axis of symmetry, AOS. Take your two zeros, 20 plus negative 11, divide by 2. Okay, next on page. 20 plus negative 11 is 9, divided by 2 is 4.5. So 9 divided by 2, 4.5. This is the x value of the axis of symmetry. No, well, it is the x value of the axis of symmetry, but I was trying to do too many things at once. It's the x value of your vertex. X value of vert. It's when the vertex will happen. In the case of our question, the x value, we could plug it into there and we could find out what the price per ticket would be to maximize the revenue. We're not worried about what the maximum revenue is. We're looking at what price would maximize the revenue, what ticket price. So we have to take this 11 plus 1x and we have to do something a little bit different here. So we're going to call this modified 3 because the other one we just plugged into the original equation. We need to go into price per ticket and we have to sub x into equation because that's what we're trying to find. So price is going to be 11 plus 1 times 4.5, and 11 plus 4.5 is 15.5. Therefore, if tickets were 15.50, it would max revenue. Yay!